welcome back. It's been a while, and there is some other stuff I am working on which I really should finish first, but this set has been with me for a little while, and the owner wants to give it to his son for his birthday, I believe. So he's just reminded me that I have it, and that's reminded me I need to do something with it. So it's a standard Bell Colt, probably a 5B5, which I have done before in a plastic cabinet, but this is one of the oak cabinets, and these are a little bit rarer than the plastic cabinets, or in fact considerably rarer than the plastic cabinets. They're not what I'd call rare, but they can be hard to find, particularly in nice condition. This one's not too bad. It's got a little bit of scuffing, a little bit of water staining. I'm going to have a word to him about redoing the cabinet, because I'm kind of set up for doing cabinets at the moment, so giving this a bit of a polish off. It's a wee bit of scratching on the sides, but overall in pretty good nick. So I'll talk to him about redoing that, or whether he just wants to leave it. It will be a nitrocellulose lacquer, so I can touch it up if needs be. Inside, standard 5-valve chassis, and as I say, I'm pretty sure this is going to fall into about the 1955-56 bracket. The speaker's been replaced. That actually looks like a Pi speaker, so I can't use that to date it. It's possibly a date code on the electrolytic. We'll have a look when we get it out. Inside the cabinet, not much to see. There is a foil antenna on the top, just like the plastic cabinets have. The speaker grill cloth, which is in really good condition, I think is glued, and then has that baffle stapled over the top of it. Nothing else in here except for the number 6, it looks like, penciled into either wall. That may have been the assembly person on the line making these cabinets. These cabinets, if you're used to wooden cabinets and radios, you'll be used to the idea that they are a veneer over a plywood or a core ply. These cabinets are straight up oak, and they do warp and they do twist a bit, but this one is in really good condition. It is pulling away a little bit. Not that it needs fixed, I don't think, but trying to do something with that. It's probably been like that from the factory. Trying to do anything with it would be more damaging than leaving it alone. Overall, cabinets in really good condition. Grill cloth's in great nick, so a wee refinish would make this look absolutely stunning. I will talk to him and see what he says about that. For now, let's put that somewhere safe, where I will immediately forget where I put it and then not be able to find it again. On that note, I'm just going to zoom out a bit, and you can kind of see the fringes of the mess that my bench is at the moment. It gets worse as you get further away from the edges of where the camera can see. Unfortunately, I'm in the middle of a couple of jobs that I haven't finished, and I'm starting to get crowded in by crap. Now that's a bit of a problem. It's not how I want to work. I hate this bench at the moment. Yeah, something I need to tidy up, but it's a whole garage problem at the moment. The garage looks like an episode of Hoarders, and I really need to get on top of that. One of my plans here, and it may be a bad thing because I may just walk away from this space, but I want to move my workbench, because this is in the garage. I want to move inside into one of the spare rooms and set myself up in there, because I find particularly in winter it's quite cold out here, and if I'm recording anything, then I tend to get the sniffles, which is a horrible thing to have when you're on camera. So if for that reason alone, I would genuinely like to move inside. So I've got some benches that I've got an idea of how I want to set up. I just need to clear out one of the spare rooms and then set that up, and then I'm going to move the essential gear inside to that room. And after that, I guess what isn't essential, I mean, I've got stuff sitting around here that has just sat here since I put it here when I set this bench up about 8 years ago. And I can only assume that if I haven't touched it in that long, I probably don't need it. So yeah, we'll see how we go. Does our Plessy TCC cap have a code? I don't think so. There's nothing on there that I could translate to a date. No 3 or 4 digit number. So the power transformer is an R68, a 52 R68, which I think is a 1952 design of that particular transformer. You see various numbers at the start, 48, 52. If anyone knows better on these, what are they, ATC or Beacon, I can't remember off the top of my head, but those transformers, the R68 bit is the code of the actual transformer. That number just seems to relate to roughly a date when these would have been made. Now this is not 1952, I'm guessing it's going to be about 55, 56. Still using the rim lock, so it's definitely an early one, but it's got the ECH 81, can't remember off the top of my head, but it's got the Novel mixer, which wasn't on the early ones. That sort of came in mid 5B4. If it was a 5B4, that would be stamped on here and it wouldn't have such a high serial number. This one's 27630, I think. Okay, first thing I want to do is power it up. Now that I've taken it out of the cabinet, I probably could have done that while it was in its box, but we're going to power it up and see what we've got. Just on dim bulb, of course. So, let me move this over. Pull my dim bulb tester in. Now the other thing that I don't particularly like about this workspace is birds. It is in the garage. It's not a particularly well sealed garage. This is an older house and birds do get in and birds poop on stuff. And I had to clean all of this off because it had a giant, or it looked like a couple of merged bird poops on the top here. Still a bit on the side. That's pretty frustrating. And it means, like for my stuff, it gets a bit of poop on it. If I'm bringing anyone else's stuff in here, I've actually got to wrap it up. So if I bring someone else's radio into this garage, I tend to put it under a drop cloth or actually fully wrap it in a blanket. It's annoying when my stuff gets covered in poop, but it's not acceptable for someone else's. So it's just another hassle. It'd be nice to be inside. Like even today, which is in summer, it's raining and cold outside. Okay, don't know if you'll be able to see it, it's dimmed right out. It did just give a brief flare, which it should do. And looks like we've got some instability. Tone circuit's working fine. Volume control's working and not scratchy, but that's not ideal. Okay, so that's probably going to be capped somewhere. That could be something in the oscillator circuit, mixer circuit somewhere, but for now I'm going to assume that caps will need doing. I haven't actually looked underneath yet, so I guess we can do that now. Yeah. Looks like a Colt. Alright, so one glaring obvious thing, and I'll bring you in for a wee look. There's a blob of something unpleasant on the bottom of the electrolytic capacitor. So the electrodes are gone, no surprise there. So I'm going to do what I always do in a Bell Colt. I will make a little tag strip with new caps on it. I'll screw it into the bottom here and just connect the wires up to that. No, I'm not going to restuff the cap. The cap is too small to restuff with modern caps to suit it, and it's just a lot of hassle for no real gain. If this was super rare, if it was one of maybe 15 left in the world, absolutely do it the best possible way. But we're talking about a chassis that was made based on serial numbers. I would say there was probably at least 20,000 of this particular chassis style made in a small country like New Zealand. There are a heap of them left. Alright, so I went and printed off the 5B5 schematic, which is one that I've actually kind of reverse engineered from a 5B4 schematic and just noted the changes. One of the things that I note with interest is that the electrolytic can in that chassis is a 40-40-10 or a 40-40-20 but on the schematic it's a 20-10-10, and that is what they typically have, I think, from memory. So either that's been replaced at some point, or more likely that is just fine and that's what they've used. More smoothing, HT might be slightly higher, so the resistors might be slightly higher here as well. It's a 1K and then a 2K2 between the stages of the capacitors. So we'll take a look at that, but as long as we've got about 185 volts on the screen and 210 on the plate, or going to the plate via the output transformer, that's going to be within Kiwi. These voltages, I don't believe they're supercritical. You may disagree, and you're more than welcome to disagree down below. Conversations we have about that make things much more interesting, so more than happy to have that conversation. So this will be, yeah, so that's a 1K, 10% wire wound. It's going to be at least a 5 watt, which is what it's spec'd to be, and that'll be our 2K2 there, I suspect. Yep. So resistors are the same, just higher capacitances. Hi bud. So what do we need to do? Alright, dogs are going mad outside. I might just go and make sure they're okay, and I'll be right back. Alright, so let's have a wee talk about what we need to do now. I have made a replacement electrolytic. This is not necessarily the way to do it, it's a way to do it. It's the way I'm doing it. I've got a 22 and 2 10s, which is what you typically find in these. This one's got some higher value caps. Now the EZ40, which I assume this has, I haven't checked, 40 or 41 should be pretty much the same. That is in fact an EZ40. EZ40 can handle up to a 50 microfarad first filter, so that would be fine. The value of cap 20 microfarads for a first filter will be perfectly fine in this instance. The 1K resistor, that's wire wound, it's almost certainly fine. The 2K2, we'll check that one once I've taken it out of circuit with the electrolytic. Just make sure that's okay. The only thing that's in our way is this little tubular ceramic capacitor down here, and that little guy is the coupling cap. So it runs from the plate of the first audio tube, the EBC41, and it runs across to pin 4 of the output tube. Now pin 4 of an EL41, we consult the good book, and this is my favourite book for finding stuff, particularly the modern valves. Pin 4, nothing there. So pin 4 is just being used as a tag, because in the circuit the decoupling cap then goes through a 1.5k resistor to the grid. Now in this instance it's actually this resistor here, which is yellow, purple, red, so that's 47 and 2 zeros, or 4k7, and then a 470k resistor to ground. And on the schematic it's got a 1.5, but a 4.7 is probably not going to make much of a difference. So this cap here is a 0.005, and you won't be able to see it, but it's marked 5,000 picofarads, which is 0.005. So because it's ceramic, it's probably okay. I'm going to leave it in there for now. It is in the way, and surprisingly the legs are not shielded in any way, and they're quite long. Like, there's just wire running, and that's really close to touching the chassis. Now I know those wires don't tend to move that much, so it's not generally a problem, but this could have been put in afterwards anyway, because certainly This cap looks kind of 1980s-ish, and the one down here looks kind of 1980s. I would expect Ducon paper caps in here, and these are polyester caps or polystyrene caps. It's had the speaker replaced. It's had the Ducon paper, wax paper caps replaced. It may have had the electrolytic replaced as well, which could explain why the values are higher. And it could have had that coupling cap replaced as well. This resistor could also be a replacement. So I think it's had work, and maybe this is how the last serviceman left it. But we're going to have to move that because that leg of that cap is going to be in our way, because I want to put this about here somewhere. So I'll drill a small hole through the chassis there and just use a self-tapping screw to mount that. And then all of the wires that go to this electrolytic have enough slack that I think we can just desolder them and solder them straight on, or even cut them, restrip them and solder them on. So that's what I'm going to do, and I'll do that off cam. If you want to see me struggle with that and make an enormous balls up, then have a look at the 5B5 Colt hour and a bit long video I did. You'll see me leave one of the wires off and then wonder why it doesn't work, which is a good reason to do this without talking to the camera at the same time. You know, I'd like to think I'm perfect and don't make mistakes, but I know better. I'm going to disconnect these wires, hook them up to this, drill a small hole in the chassis and mount it. And then once that's done, I'm going to come back, we'll flip it over and we'll put it back in the dim bulb tester, and we'll see how our motorboating is going and whether it's stopped playing up. I suspect that that's going to be our issue. We'll know shortly. Alright, before I go too much further, I just thought I would explain again. I'm pretty sure I did this in the 5B5 video, but I'll do it again here because it is useful information, and it can be a little bit confusing if you haven't worked on one of these before and expect it to be laid out like it is in the schematic. We've got the rectifier here, which is an EZ40, and we come out to the first filter cap, which is should have a voltage of about 260 volts on it according to Bell's schematics. It goes through a 1K resistor, and in the old school sets that would have gone through a field coil, but these modern sets have a permanent magnet speaker, so there's no need for that. So 1K 5 watt resistor, and then we have 210 volts at the second cap, and then we go through a 2K2 1 watt resistor, and we have 185 volts at the third cap. So it's like a double pi filter, 3 stages of filtering. The important thing is that this is neat and tidy, and it would make sense if it was done that way. And on some sets you will see these 2 resistors actually soldered directly to the top of the electrolytic can, so that it's all nice and compact. But at least in some of the Bells, that's not how you find it. So the valves we care about here are the rectifier, which is over in this corner, and the EL41, which is the output valve, which is just here. What we've got here is this red wire down on the chassis. That comes from pin 7, or the cathode of the rectifier. That's the output. So that's our unfiltered DC voltage coming from the rectifier. And it comes to this first cap, which in this case is this pin here, and there's nothing else connected here. So that can be a little bit confusing. But if we look at our diagram, you can see that this is pin 7 here. That's that red wire coming to the cap, and there is nothing else connected to that pin on the capacitor, but there should be a 1K resistor. We have to go back to pin 7 because this 1K resistor is actually connected back to here, not to the top of the capacitor. So you can see this 1K resistor's here, and what you probably can't easily see is that one of the legs goes down to pin 7 down there. The other one comes over to a tag strip here, and we'll have a look at that in a second. So that is all the things that should be connected to that first filter cap, just that 1K resistor and the 20 microfarad capacitor. And that is in fact all that's actually connected to it. It's only 2 things connected, but they're connected at the rectifier, just for added confusion. If we go through that that 1K resistor, then we come to this tag strip point, and the 2K2 is also connected to there. So that's our junction of the 1K and the 2K2. So that's this point here, the 210 volt point. And we see we should have the second filter cap off there. So on that tag strip are the two resistors. There is also a capacitor here. We're not going to worry about that. And we've got this red wire here which snakes around and comes into our second capacitor. And then there's another wire off, it's a thick red one, which is heading off to the output transformer. And if we have a look here, on this second side, or after the 1K resistor, where it connects to the 2K2, it also connects to the output transformer. And that red and blue wire is what's the thick red and blue wire here going to the output transformer. So that's correct. The only other thing is this little capacitor here, which is connected to pin 2, which is the plate of the output valve, and that's actually this capacitor here, and this is a tone compensation cap. So it's straight across the output transformer. So that's that point on the second filter cap, and then this resistor goes directly to the third cap, which is what happens. So this is the second point here, through that resistor to the third point. There's that third capacitor there. So when you're looking at this schematic, it can be a little bit confusing, but this is how Bell drew it. It's not completely straightforward. This probably makes it a little bit easier to follow. That's basically what's happening. But yeah, not the easiest thing to get your head round how it's done here. So I just wanted to go over that and make sure everyone sort of understands how the wiring is done. And then of course finally there is a wire that comes off that last cap, this one here, and goes up to pin 5, which is the screen. So I'm just going to go through now. I'm going to snip the wires around here, put this in, connect them up to this, and then I'll come back. And I know some of you guys like to actually watch me do this, and I do get people say that they enjoy the kind of the long form follow me do it videos, and I'm not stopping doing those, but in this case if the camera's on I'll waffle and it'll take me 10 times longer. So I'm just going to do it, and I'll come back, and if you want to watch it in long form, go watch the other 5B5 video I did. Oh, while I think about it, this is a replacement capacitor, and in fact the original capacitor would have been here, and it wouldn't have fitted after they replaced the speaker, because this is a Pi speaker and it's a much bigger magnet, and so not sure if you can see it down there. We'll make a bit of room so you can kind of see down there, but the speaker actually half covers that hole where the electrolytic should have been. So it looks like they've chassis punched this and then put a new electrolytic in here. So that was probably all done at the same time. Alright, I'm back, and I don't think I've made any mistakes this time, but I've said that before too. So just to recap, here's our new electrolytic replacement, a bundle of 3 caps. The ground is on this lug here, which is screwed down. There is a wire running from the back of that to a ground point, so it is positively grounded. The first filter cap is here, and there's a red wire here, which is the first filter cap wire that runs back to the rectifier. The second cap is this one underneath here. That runs back to the junction between the two resistors. And the third one, which is this top one, runs to the end of the 2K2 resistor, and also to the screen grid pin 5 of the output. All the wires are back on where they should be. Everything's wired up. Output transformer's wired up here as well. Fairly sure I've got everything right. And it should work now. So I guess the next thing we can do, actually the next thing I'm going to do is just check these two resistors. And this one should be absolutely bang on fine because it's a wire wound resistor and they tend to just not drift. They're either there or they're open. 0.996K, so that is almost perfectly 1K. These, however, do drift, but they also have quite a high tolerance. I'm pretty sure these resistors are 20%. What do we got? Just over 2K, so at 10% that would be fine. I'm going to check the voltages and just see what we've got. Now the voltages will be designed, in fact it says on the schematic, so I don't even have to guess. Voltages with a 20k per volt meter, so that's an analog needle meter. A 20k per volt meter will put a reasonable load on the voltage, and so your voltage readings will be lower than if you read them with a modern digital meter, which I think is something like 10 meg input impedance. You'll get a higher reading with a modern meter than you will with the old meter, so if it's a bit over, I'm not going to be too stressed. We're going to plug back in. My bulb switched off. Flip this up so you can see the bulb going, and we're on. I'll set it to about half voltage so we can hear if we've still got any problems. And then I am going to check this voltage, which is our main straight from the rectifier. It should be 260 volts. I would expect we might read 275-ish. I guess we'll find out. Alright, so our usual expected initial flare. Wait for things to warm up a bit. Starting to conduct quite heavily. That's too bright. Something's not right there. Not happy. We should have been seeing voltage. We were seeing very light voltage. That was way too bright for a 5 valve, unless I've changed that bulb out. No, it's a 75 watt. It should not have been drawing that much. What have I done? Let's go looking. This is always the fun bit, when you've screwed up but you don't yet know how.
One eternity later.
I don't think I've done anything wrong. What are the chances we've got a faulty EZ40? Unlikely. I mean, we could have a damaged power transformer. Let's take the valves out. So, with only the rectifier in, let's try again. And all I'm looking for here is for that bulb to flare up again. Right, so it's either the rectifier, it's my new wiring. What have I done? Double check your work. You probably goofed, you idiot. Alright, I'm going to turn the camera off for a minute and then ponder my life choices. Well, it wasn't me. Although I normally check my capacitors before I put them in, just to check that they're the right value. This one the ESR is quite bad. 0.15 of an ohm, and I think that's pretty much just probe resistance. That Nishikon cap is a dead short. So, there's my problem. Kind of my fault for not checking it, I guess, but I've never ever had one of those caps be DOA or even fail, to the best of my knowledge. So that's interesting. I shall get another. Grabbed another. And that's what we should see, nothing. And if we go to capacitance, .77, so close to 21 microfarads, which is near enough for an electrolytic. I guess pleasing to know that I didn't screw up, but yeah, that's really annoying. So I'm going to replace that cap and we'll try again. Alright, so clearly something went wrong there. Like I said, I've never had a Nishikon cap fail, short circuit, or any other way on me before. This new experience. I may pull that apart later and see if there's anything obvious in there. But yeah, interesting. so let's get back to doing some voltage measurements. What I'm going to do is put all the valves back in. Right, caps back in, valves back in rather. Meter on volts, not ohms. I want to measure the impedance of Lake Benmore. It's one of our big hydro schemes if you're not from around here. Pretty sure I've told the story before. I used to work at Dick Smith after school when I was a young fella. And I worked with a guy called Simon who was demonstrating a fancy multimeter to a prospective customer. He was showing him all the things he could do with it, like measuring volts, and he put it in the wall socket and it was on ohms, and there was an almighty kaboom.
Where's the kaboom?
And a big green cloud of smoke surrounding the main counter where he was standing and where the customer had been standing, and when the smoke cleared, the customer had gone with no idea where he went. He just left, and I don't blame him. Suffice to say, Simon did not sell that multimeter. Yeah, a lot of hijinks we used to get up to in that store. Had a lot of fun there. Manager was a guy called Phil, who I really enjoyed working for. Very smart guy. Still around, I believe. So, Phil, in the unlikely event you're watching this, g'day. Alright, we're on via bulb, and we're on small flare up as expected. Already starting to see some voltage coming up there. So 265 and then dropping back to a steady voltage. The filament of the bulb is just barely glowing, and we've got audio coming through the speaker. So on dim bulb we've settled down to 240, the next cap across, not that one, it's 210, and the last one in the chain 182. So that's pretty good. We should be 260, 210 and 185, and that's on dim bulb. Our bulb is fine, motorboating has stopped.
The train for kayak crew won the year, and that was, I think, quite a surprise for a lot of people. But yeah, she
seems good to me.
Right through that Olympic campaign and afterwards, that
Right.
that 10 gold.
Let's go full noise and see what happens. Check the voltages. I expect they'll have come up a little bit. So we're at 280, 240, and 202, so about 200. So we're a bit high. I'm pretty happy with the performance.
I just said metal like it was a bird. Oh, never said that before. Sorry.
If you work in the country, you probably know what a cow sounds like.
Yep.
Join the thousands of seven.
Starting to get into LED noise, which is pretty typical here in the lower frequencies. Happy smiley station there. So yeah, look, everything seems to be working pretty well at this point. Reasonably happy with that. So as far as I'm concerned, that is fixed. Remember, not a restoration, it's a repair. One thing, it might need a bulb, needs a dial bulb. Okay, these are the bulbs I use. They come from RS. I don't know if they're still available. These are 6.3 volt long body screw thread. RS part number 104-806. come in a pack of 10. Like I say, I don't know if they still have them, but these are the ones I use for this particular style of set that requires this bulb. So in most Colts the bulb is just spring clipped on. That sleeve is to stop the top of the cabinet glowing. Probably not necessary in a wooden one, but in the plastic cabinets, if you don't have that, the light spills out the side of the bulb and lights up the inside of the cabinet, and you can see it through the cabinet. No doubt just something they put on as a matter of course, so we'll put it back. It's been there for, well, 70 years or so. 65, 70 years, yeah, something like that. Alright, but you can see the glow at the top of the dial. That will be much better in the dark. That's pretty good. It's doing its thing. But for now,